29.
Oh, okay. These are just jokey slides. Okay, this is our real title. While frequency is affected by various volumes and types of liquid. I don't care. Okay. Okay, so our purpose of this lab was to study the changes in sound, particularly frequency when the amounts and types of liquids are varied. And our hypothesis was that frequency will decrease as amount of liquid and density increases. So we used 4 different liquids and different measurements, and we just deep glasses basically. Yeah, so this is the equipment we used. We don't have a picture of our diagram because it was literally a glass of water with a microphone that we held over it. But all you needed was a glass cup. Ours was literally a cup, not an SI units. And then those are the amounts and types of liquids we use. And we just recorded in Logger Pro graphs of sound pressure versus time. Okay, so really our background wasn't much, and we just used the equation for frequency, which is velocity divided by wavelength. Yeah, and we had these theories that if you wanted a low frequency, you'd want a small velocity over a large wavelength. And then when you wanted a high frequency, you'd want a large speed over a small wavelength, so little tiny waves. And then also, density was kind of like a side endeavor for us. We didn't record actual densities, and that's something we'd like to go back and do if we had more time. But from research, we found that milk and water usually are about the same density, if not milk is more, and then oil is less. Soda was weird for us. We used Coke Zero. And if you've ever watched people put cans of soda in water to see if they're dense, regular soda usually floats because it's denser than water. Diet soda sinks because it's less dense. And so, or reverse, I'm sorry. So Coke Zero is like a weird in between, so it's kind of a wild card. Yeah. Yeah, it's weird. Okay, so our procedure was really basic. We just filled a measuring cup with the amount of liquid that we wanted and put it in a cup, and we held the microphone, we pressed collect on Logger Pro, and we dinked the glass. And we only collected data for a second for each dink, and it was just, yeah, interesting. Okay, this was a big part of our experiment. The top graph is what was recorded in Logger Pro. We let it go and then we dinked. But that didn't give us what we wanted to study. So if you go under additional graphs where you find the histograms and such, you can create an FFT, which is the cool graph, and it stands for fast Fourier transform. And it creates a graph that is instead of a function of time, it's a function of frequency. So I'm going to switch it here. These peaks are just frequencies. It doesn't matter. It doesn't go in the order of the experiment. And in an ideal experiment, like if you had a tuning fork, you would have one peak, one frequency. Obviously ours wasn't ideal. There were other things going on in the room. And yeah, so we had several frequencies. So what we did for the experiment was we went through and we found the highest peak, which was right here, the frequency emitted when we clicked the glass. And we made graphs of those. Okay, so we just plotted our data. So we did 4 trials, right? Yeah, and we just plotted the highest frequency, and we just linearized it. You can just go. That's it for oil, water, and here. And this is all of them. This was kind of our chance at figuring out density. And it didn't really follow a particular pattern. The last 3 volumes kind of follow a pattern. The blue is on top, which is water, and then the lowest is soda. But the first trial doesn't follow that same pattern. So we kind of decided that density didn't really affect anything in our experiment. But there was some error. We didn't dink the glass in the same exact place every time, so that could have made an effect if we dinked it where the liquid was, or just air in the glass. We dinked it with different
loudness and stuff. And so that could have maybe a little bit. And also pouring the oil is very tough. So there probably wasn't an exact amount of.
Next time, like I said, we'd like to measure the densities manually. And then Doc was talking with us, and he suggested it'd be cool to study frequency change when the carbonation of soda changes over time. It's less bubbly, so that'd be kind of cool to study. Yeah, in conclusion, our hypothesis was correct. The frequency decreases. That's a typo. So to summarize it for you guys, when there is more liquid in the glass, it has more of a mass to vibrate that needs to move. So if you have this glass and it's empty, it doesn't have a lot of mass it wants to move. So it can kind of echo like this. But then when it has, and it's creating lots of little tiny fast moving waves because it can vibrate a lot. But when it's massive and it has a lot of liquid in it, it can't vibrate as quickly. So if you're thinking of an empty glass, you're gonna see sound waves like this. And then if you're thinking of a full glass, it'll look like this. It all comes back to like sound waves in the glass, if that makes sense. So they all come back to that same equation of velocity over equation. And like, once again, density didn't appear to follow a pattern, but we'd like to investigate that further in the future.
Thank you. Are there any questions? Thanks, guys.